roughly 85% of reality is invisible. And right now, entire clusters of beautiful spiral galaxies and stars are being held together by something no telescope has ever photographed. A mysterious, completely invisible substance that works as a kind of glue, holding our reality and the universe as we know it together. For decades, astronomers struggled to explain why. Then, one scientist named Vera Rubin took up an idea that had been brushed off 90 years before. What she found paved the way for the world's newest, most advanced observatory, named in her honor, and tasked with uncovering the secrets of dark matter, mapping the universe, and maybe, just maybe, finding Planet X. But something interesting happens when you take up the task of mapping the entire universe. You find out that maps have a strange habit of lying, unintentionally and by omission. Because every map in history has eventually revealed the same truth. They're all incomplete. Lurking near the edges are the sea monsters and dragons and fears of eras before. And beyond those edges is the realm of the unknown, where no one dares to go and no chart has ever recorded. Will the world's most advanced observatory, tucked away on a mountaintop in Chile, soon create humanity's most complete map of space ever? What is dark matter, really? One of the greatest mysteries of the final frontier. Who was Vera Rubin? And with the sea monsters and dragons of old world maps transformed into cosmic mysteries, like lost planets and voids in space, what would happen if we filled in every last blank space on our map of what was once the unknown? Join me as we unravel all this and much more and enter the Codex Legendarium. I'm Shelby Melanson. Welcome back to the celebration. The most powerful observatory mankind has ever built is celebrating its first birthday, and there is a lot of star watching involved. In part 1 of this series, we talked about how this facility blew the doors off every space surveying telescope that came before it during its test run alone. Now it's just weeks or even days away from starting a 10-year mission to film a movie of the entire southern sky in unprecedented detail, and with any luck, create the most complete portrait of the visible universe ever assembled. But before we can understand what the map might reveal, we need to confront a far stranger question. How do you map something that you can't see? Because hidden within the motions of stars and galaxies lies evidence that most of the universe may be invisible. And the story behind that begins with a scientist named none other than Vera Rubin. Vera Florence Cooper Rubin was fascinated with studying how galaxies in our universe rotate. The short version of her astronomy-changing discovery was this. Based on the laws of Newtonian physics and gravitation, scientists believed that spiral galaxies rotated like this. That the cosmic bodies close to the center, or close to what's called the disk, would rotate significantly faster than those at the edge. That's because the gravity is weaker the further away from the center that you get. But when Vera and fellow astronomer W. Kent Ford Jr. measured the speeds of stars across 60 different galaxies, including our closest galactic neighbor Andromeda, she saw this. Something seemingly impossible. Stars at the edge rotating at the same, relatively fast speed as those at the center. This is the moment when she knew that she had found something incredible, a violation of the laws of physics in action. With the stars inside a galaxy moving at that velocity, and when you add up all the mass of that visible matter that they measured, the objects in the galaxy should be sent flying out into space at that rate, because the gravity at the outer edge wouldn't be enough to hold them in place on its own. Which left only one possibility, that something, some unseen substance, was acting as a kind of glue, exerting huge gravitation throughout the whole galaxy, enough to pull the outer stars and other objects along at the same speed as the closer ones, and also preventing them from being flung out into space. It was a theory first hinted at by British physicist and engineer Lord Kelvin roughly 90 years earlier in 1884. He, too, had noticed this weird discrepancy with the speed of stars, and his suggestion was that there were something called dark bodies, which were invisible and which he said surrounded the sun in the solar system. Nobody took him seriously, but Vera's findings proved that the scientific community was wrong to brush it off, to the point that her work created an entire new subfield of astrophysics. Fun fact, some of her research was done at the Kitt Peak National Observatory near Tucson, Arizona, and another chunk of it was done at the Lowell Observatory in Flagstaff, which happens to be the same place that another American astronomical history maker, Clyde Tombaugh, made history by discovering Pluto during his hunt for the ever-elusive, still to this day, Planet X, or Planet 9. And also where this mug is from. Thanks to my awesome in-real-life friend for bringing it back to me on your recent visit. You know who you are. Anyway, go check out this video for more info on Pluto. These days, we know dark matter is out there, and we know there is a lot of it. It's roughly 85% of all matter in the universe, after all, and we know it has a ton of gravity. But we know next to nothing else about it. And even now, after Vera Rubin, the person, passed away in 2016, her hopes of uncovering its true nature are still very much hard at work. And the observatory named in her honor, which has to be just about the highest honor possible for an astronomer, might just be able to shed some light on it. Vera Rubin's story is honestly nothing short of incredible. And if nothing else, well, you look at the incredible images from the observatory, again, named in her honor, you might want to know just a little bit more about how it got its name. Native to Philly and growing up in Washington, D.C., she discovered her love of space in the exact same way that I would bet most of us did, from looking at the stars out of her window. And it wasn't long before she turned that love into making her first telescope out of cardboard with help from her dad, and starting tracking the paths of meteors. Quote, "I decided at an early age that we inhabit a very curious world. Even then, I was more interested in the question than in the answer." Unfortunately, given that she graduated high school in the 1940s, the world wasn't exactly super supportive of a young woman who dreamed of astronomy. Thankfully, she ignored some advice from her high school teacher that she should stay away from a career in the sciences, and went to a college famous for uplifting another female astronomer to greatness back in the 1800s. And she also refused wholeheartedly to give up on her dream, even after getting rejected from Princeton's astronomy department for quite literally no other reason than she was a girl. They didn't let girls enroll in that particular department until decades later in 1975. And she dealt with quite a lot of that same thing during her entire education and career, as you might expect. Later on, she was accepted by Harvard, but actually opted to get her master's at Cornell, despite its underwhelming 4-person astronomy department, which was teeny tiny at the time, since her soon-to-be husband was a graduate student there already. And finally, by 1954, she did it. She earned her doctorate of philosophy in astrophysics from Georgetown, and somehow pulled it all off while becoming a mother of 4. I know. Little did she know she would go on to make such incredible contributions to astronomy that she'd also later receive honorary doctorates from Harvard, Yale, Grinnell College, Smith College, and yes, would you believe it, none other than Princeton University. I bet they had some regrets about that one. While we're adding to the honors list, she was dubbed one of the 50 most important women in science by Discover magazine back in 2002. That's on top of receiving a ton of awards, including the National Medal of Science from then-President Bill Clinton himself. She also had a bunch of research funds and science prizes named after her, not to mention an asteroid, an area on Mars, and NVIDIA's next-generation AI superchip, containing a CPU named Vera and a GPU named Rubin. Plus, her face appears on a special 2025 edition quarter created by the United States Mint. The New York Times described her legacy as, quote, "ushering in a Copernican-style change in our theory of how the cosmos works." A bunch of prominent scientists also argue that she was unjustly and purposefully overlooked for the Nobel Prize. You decide that one. But here's the quote. She has won every scientific award that a scientist can win except the Nobel Prize. And at this point, it seemed more like a glaring omission on the Nobel Prize Committee's part. Maybe the best part of her legacy is that she also spent her time encouraging girls to chase the stars, figuratively in life and literally as aspiring astronomers. She gets major points in my book for that, as well as for her bravery to defy the odds herself. So, we have a new shiny observatory with a world record-earning camera and telescope inside, with a name that honors the history of one of the greatest ongoing mysteries about our universe, dark matter. We have a set of visually stunning, mentally unbelievable images that blow the doors off other ground telescopes after a 10-hour test run alone. We have an entire arsenal of new asteroids and celestial bodies discovered that basically obliterates the standard rate at which we map our universe out of the water. We could very likely see some of the universe's most elusive, most speculated about objects, things that have gained near legendary status, like, again, Planet X, for the first time ever in human history. And all of that means that we're about to be well on our way to filming the first ever high-definition celestial movie of the cosmos, and creating a full, complete map of the southern sky, like a Google Street View of the stars. But if we can really do all that, if the Vera Rubin Observatory really opens up a door to space that we've never been able to walk through, or rather had good enough eyes to see through, what will that mean for our exploration of the stars? Throughout all of history, we have made maps. Indigenous people of Polynesia navigated small canoes across thousands of miles of open ocean, using the wind, waves, and stars as their guide. Norse Vikings from Scandinavia set sail for uncharted territory, following bird migrations to far-off lands like the Faroe Islands and Newfoundland. Greek myth told us of the Pillars of Heracles, which marked the boundary of the known world, and beyond them was the unknown. In the medieval period and the Renaissance, the world's finest cartographers drew sea monsters and windheads at the boundaries of their maps to warn sailors of the dangers lurking out at sea. But the one thing that all of these have in common is this. Every map that humanity has ever made has had blank spots. It has an edge where everything past that edge is just unknown. And there was a word, or rather a phrase, to describe exactly that. Hic sunt dracones, or, from Latin, here be dragons. Inspired in a literal sense by the dragons and sea monsters from Old World maps, the term describes the perils and uncertainty of unexplored territory. Beyond its bounds, anything could happen. Fun fact, that specific phrase never actually showed up on European paper maps, per se. Instead, the only artifacts it was ever found on came from Asia in the 1500s. The Hunt-Lenox globe, and an ostrich egg globe, two of the oldest globes ever found. But what did show up on maps, and way more commonly by the way, was the phrase, here be lions. That, as well as the less dramatic but still cool terra incognita, or literally land unknown, were particular favorites on maps from ancient Rome. Though neither of those caught on verbally, I guess dragons just has a better ring to it. But I digress. The reason the Vera Rubin Observatory is so special is because it represents the opposite of all that, or maybe even the death of here be dragons. The possibility of a not-so-distant future where all those blank spaces disappear, where the edge of the map isn't the edge anymore, because there is no edge. And yes, the scope can only map the southern sky, but you get what I am saying here. In theory, this level of technology could mean that we won't have to guess what's out there anymore, because we have a full and complete map. But if that really happened, what would that mean for humanity's drive for exploration? Well, one highly unusual author came up with a poetic thought experiment to ask exactly that. Imagine for a second an empire where cartography became so advanced that every single inch of the entire kingdom's territory was recorded. if its details were so precise that every foothill, every stone, every divot in the road were known, what would happen? That's the premise of a one-paragraph-long short story called On Exactitude in Science, published in the 1940s by Argentine author Jorge Luis Borges. The story is literally one paragraph, written as though it's part of a full book from the 17th century, which in reality, that book doesn't exist. Here is the first half of it. Quote, "In that empire, the art of cartography attained such perfection that the map of a single province occupied the entirety of a city. And the cartographer's guild struck such a map of the empire whose size was that of the empire, and which coincided point for point with it." In other words, the map's level of detail meant that it eventually grew to be the same size as the empire itself. Sounds a tiny bit reminiscent of the fact that you'd have to arrange 385 4K televisions next to each other in order to display one single image from Vera Rubin in its full glory. Here's the rest of that short story. Quote, "The following generations, who were not so fond of the study of cartography as their forebears had been, saw that the vast map was useless. And not without some pitilessness was it, that they delivered it up to the inclemencies of sun and winters. In the deserts of the West, still today, there are tattered ruins of that map, inhabited by animals and beggars. In all the land, there is no other relic of the disciplines of geography." The point being here, this map got so big that using it just became ineffective, and I don't even want to think about having to try to store this thing. So they abandoned it. And now there are a lot of parallels between this story and what's going on with space surveying right now. Official estimates say that the Vera Rubin Observatory can collect 20 terabytes of data in a single night. Plus the whole being somewhat challenging to even look at, given the size of an individual image, not to mention the sheer volume of individual images being taken and the number of alerts about changing phenomena in space that the observatory can put out per night, somewhere, like we said in part 1, in the 800,000 ballpark. Now, in no universe am I saying that the Vera Rubin Observatory's map would somehow become ineffective. As a certified space nerd myself, I am literally on the edge of my seat over what the scope is going to uncover about our universe. But it's an interesting thought experiment when you consider that we now have an instrument that can produce such massive amounts of data that we wouldn't even be able to sort through it, much less be able to pick out celestial changes in events of interest captured by it, without running it through gigantic AI-driven data centers to do that work for us. Here's another thought. Pluto was discovered by one single American man who inspected images of over 1.5 million stars with nothing but his own eyes over the course of about a year. He discovered the celestial body with his own eyes via an image that he pressed the button to capture himself. No matter what Vera Rubin finds, whether it's the secrets of dark matter or Planet X or anything else, AI is going to be the first one to flag the image. It'll get looked at by human eyes after that, of course, but will we still be able to say that it was a human who discovered it? It's very possible that we have now entered the age where computers will locate all new entities in the cosmos, and that humans will never technically be the first to find something in space ever again. It's food for thought. Again, I am totally all for looking deeper into the beautiful universe that surrounds us. I can't wait to see what this observatory finds, and logistically, it all makes complete sense. The cosmos is so big that it's beyond human comprehension by a long shot, and we don't even truly know how big it is past the boundary of the observable universe. So naturally, we're gonna need some help to sort through all of that matter. But no matter what you think of the method, I do think it's clear that we're entering a new era of human exploration. And in some ways, maybe it's not so different from the maps of the Age of Discovery, where Europeans set sail back in the 15th century. Then it was sea monsters and krakens and dragons or lions, and the blank space at the edge of the map. Today, we've replaced those with dark matter and energy, plus mysterious radio signals we can't identify from deep in space, gigantic untapped voids outside our solar system, and again, the ever-elusive Planet X. The symbols may be different, but the meaning and what they represent is the same: unmapped reality. So, what would a completed map really look like? And what would happen if there was nothing left for us to explore? Maybe that sounds like a loaded question, because if not space, there are plenty of other things to look at. We have more completely mapped the geography of Mars, the surface of Mars, than we have the bottom of our own oceans. But space is called the final frontier for a reason. Even though there's still so many unknown frontiers to be explored right at our doorstep, the quantum realm, the brain, human consciousness, the depths of the ocean, simulated realities, and artificial intelligence, nothing is as big or as all-encompassing as the thing that surrounds our pale blue dot itself. If you ask me, exploration and curiosity is part of what defines us as human beings. At the same time, the exact quality of being unexplored is what fascinates and captivates us about space in the first place, plus a million other things that we've only scratched the surface of understanding. I'll leave you with a quote from Antarctic explorer Sir Ernest Shackleton. "It is in our nature to explore, to reach out into the unknown. The only true failure would be not to explore at all." What do you think? Are we on our way towards a complete map of the visible universe and discovering the secrets of the invisible dark matter? What do you think Rubin's almost all-seeing eye will actually see out there? And what do you think about humanity's drive to explore the unknown? I would love to hear your thoughts all about this in the comments, and if you have an idea for something you'd like to see a future episode on, let me know. And of course, if you enjoyed this deep dive into mysteries, myths, culture, and science, please take just a second to like and share this video, hit the hype button, which is the latest way to tell YouTube you like what you see, and if you want to see more, subscribe. I upload every Tuesday, and it really helps get the word out there. Until next time, stay curious and stay legendary. And also, real quick, before you go, YouTube thinks you will like this video next, so you might want to check it out. Thank you.